Like it looks good. This is stupid for a lap. Like, I got halfway through.
Okay, guys, so let's start. Okay, so as I told you guys in this chapter, what I'm doing here in this chapter is simplification. If you have a logic function, how I can simplify it. Okay, someone can ask me, we have already done that, so why we do it again? Okay, yes, we did it, but using algebra and algebra manipulation. Okay, so what we're gonna do here, the result you will get the same like algebra manipulation. Okay, if you do it correctly, for sure it will be the same. Okay, however, usually we use maps because it's much easier, as you will see by yourself now, it's much easier than algebra manipulation. Okay, so this is just another approach, and usually we use this approach for simplification of functions. Okay, so the idea you can see here from the English word maps. Yes, we have a map. Okay, that's why, as I explained last time. So this is what all this chapter is about. Okay, given. So as I told you last time, if you have two variables, okay, so here we are gonna have a map, as you see here. This map, in case of two variables, it has 4 squares. In case of 3 variables, as you see here, it has 8 squares. In case of 4, you have 16. So the relation is 2 to the power of 2, 2 to the power of 3. This is the number of squares. 2 to the power of 4. Is that okay? You remember this relation before, right? If you have n bits, okay, 2 to the power of n. Do you remember this relation in the very beginning of this course? The answer is yes. This is actually all possible cases or all combinations. Okay, so if you have n bits, how many different combinations you have? 2 to the power of n. This is true. This is because every combination. So, for example, in case of 2 variables, you are going to have 4 combinations. Okay, like for example, 0, 0, 0, 1, 1, 0, 1, 1. This is all the different combinations for 2 variables. Okay, this is because every combination or every row is represented by 1 square here. You got what I'm saying? So here I'm gonna every row or every case, okay, is represented by 1 square here. That's why, yes, if you have 2 variables, that means I have 4 cases or 4 combinations. That's why I have 4 squares. Is that okay? So you will see right now. I started last time with 2 variables. For sure, honestly, 2 variables should just very easy. It's very small. You can it's easier to do it using algebra manipulation than do it using maps, honestly. So, but usually we use maps for 3 and 4 variables. Okay, someone can ask me, what if I have more than 4 variables? Okay, what if the circuit has more than 4 inputs? Okay, what can we do? For sure, you can use maps, but in this case, it would become more complicated. Okay, that is why most of the textbooks usually only work on 3 and 4 variables. If in one lab, I will give you a circuit that has more than 4, but I'm not going to ask you to do it manually. I will ask you to use either, the digital program, the digital logic simulator you are using in labs, it can do that, it can do it, or some online websites can also do it. So you can go to the website, online website, you can just input the function, it can do the maps. And so anyway, so in this case, you can use computer. So in this course, most of the time it's going to be 3 variables or 4 variables when you use maps. Okay. So last time I started with 2 variable maps. Okay. So here I told you this is how the map looks like. Okay. So here we define regions or areas. So here, when I say 1, what it means? Let me use a different color. When I say this is Y, this is the area of Y, what it means? It means if you look at this area, you can find almost the term Y is here, Y and Y. Okay? If this is the area of Y, So this part here is the area of y prime. So if one area is x or y, the other area should be x prime or y prime. Okay. So as you see here, so if this is the meaning of it, the meaning of it is y here in this square and this square, we have the term y. But any other squares should have y prime. That's why you can see y prime and you can see y prime. Same thing here for x. When I say this is the area of x, this is the area of x, okay? So that means the squares in this area have x, as you see here. Also, it means any other squares other than this area, they should have x prime. So you understand? Again, guys, listen to me. If you understand how can we do it in two variables, it will be almost the same thing. I will repeat again in case of 3 variables, in case of 4 variables. Okay, for sure there are some little changes, but the core idea is the same. Okay, so here what I'm saying, this is the way you have to read. You have to read this. So there are several things you should understand. Number one, every square here is actually related to one row, as I'm going to explain. Okay, so that's what you should understand. Number two, when I give you a map like this one, what it means? It means this is the area of y. That means the term y should be here in all squares in this area. Okay? What it means, any other area should be y prime. Same thing when I say this is the area of x. Okay? So here in this squares you can find x. Any other area you can find x prime. Okay? Now so using this concept, using this idea here, look here. So here, this one should be x prime and y prime. Why? Because this is in the area of y prime. Because this is the area of y, so this is the area of y prime. And also, this is the area of x, so this is the area of x prime. Okay? So this one should be x prime, y prime. This one should be x prime because it's in the area of x prime, but it's in the region of y. This one should be x. It is in the area of x, but it is the area of y prime. And this one should be xy. Okay? And also, you know, min terms. I explained min terms before, and we're gonna have quiz today about min terms. Okay? Remember, when I tell you x prime, y prime, this min term is 0. Okay? Remember what I said. Here, if you wanna write the min term for this one, remember, so it has to be x prime, y prime. Okay? Because any 0, you have to make it, you have to take the prime to make it 1. Okay? Also, if I give you, that's what I said last time as well. If I give you the midterm, you should get the number out of it. How can you do that? Any prime should be corresponding to 0. If there is no prime, it's corresponding to 1. So here in this case, because this is the area of x prime, y prime, so this is actually 0, 0. Okay? Which is midterm 0. So this is the square of midterm 0. Okay? This same thing here. This is 0 and 1, right? So this midterm x prime y is corresponding to this case 0 and 1, okay? Which is actually midterm 1. This one here is 1 and 0. 1, 0 this way. This is number 2. This midterm 2. This midterm 3. Okay, just let me finish. Just one second. Okay. That means this is 1 square for each midterm. 1 square for each midterm. The first step you have, okay. The first step, again, guys, what I'm doing here in 2 variables, same thing I will do it in 3 variables, same thing I will do it in 4 variables. The first thing you should understand the map itself. That's what I'm explaining. You should understand here in this map what it means when I say this is the area of y, this is the area of y prime, this is the area of x, this is the area of x prime. You should understand this square is corresponding to midterm 0. This square is corresponding to midterm 1, midterm 2, midterm 3. Okay, what it means, and it's even confirmed by the term here. Okay. The second step you should do, the next step is, given a truth table, if I give you a truth table this way, you have to map the truth table to the map. You have to represent this truth table in the map. How can you do that? Very easy, very simple. If you look here, guys, midterm 0 is 1. Okay, because midterm is 0, and I know this is the square of midterm 0, I'm gonna put 1 here. Very easy, very simple. Midterm 1 is 1. So here I know this is the square of midterm 1. So here, okay, I can put it here, just look it. This is midterm 0, and I know midterm 0, this is the square of midterm 0. I'm gonna put 1 here. This is midterm 1, okay? So that means I know this is the square of midterm 1, so I'm gonna put 1 here, okay? So here, this one is 0, I'm gonna put 0, I'm gonna put 0 here, okay? So again, what I didn't do anything. All what I did, guys, is I have a truth table. I'm gonna represent the function in a visual way, this way. That's it. So this should be equivalent, the same thing. So if I give you a map, or I give you the truth table, they're the same, right? So you can easily if I give you a map, you can make a truth table. If you can make a truth table, you can make it with the map. I didn't do anything. I just represented the function in a visual way. That's all what I did. This is the step number 1. Step number 2, once you do that, you have to work on the map itself to calculate the simplified functions, as I will tell you, as I'm going to explain. So step number 1, given a truth table, you should represent the truth table in a map. Number 2, give it the map. I'm going to explain how can you calculate the simplified functions. Yes, now I can take question.
Oh, so this would be sum of products, correct?
Yes, this is a very good question. Here in this chapter, this is a very good question. I can't say sum of product or product of sum, any one of them better than the other. Okay, as I said before, I need both of them. Sometimes both of them are usable. So I'm going to use this one if I want to represent the function using NAND. I'm going to use this one if I want to do it using NO. Okay. So what I'm going to do is in the first 3 sections here, I'm going to focus on the calculation of the simplified functions using sum of product. Okay. And then in this section, I will explain how can I use the same techniques. The same thing I explained here to calculate it in product of sum. So my answer is yes. In this part here, in this section, I'm going to focus how can use maps to calculate the simplified function in sum of product, and then after that I will show how can you do it using product of sum. Is that okay? Any other questions? So 2 steps. Number 1, you have to represent the function in represent the function in a map. Number 2, as I'm going to explain, if given a map, how can you calculate the simplified function much easier than the way we did in algebra manipulation. Okay, so let's explain here. For example, as I said before, guys, number 1, remember what I said because this was really a very important topic. Number 1, and that's what I'm going to test you today. So you have min terms. For example, in this function, the min term here x prime, y prime, and here you have x prime, y. Okay. And I told you any function if it is actually the summation or the all of the min terms. So in this case should be m0 or m1. That's what I said. So I can represent in this function x prime, y prime, or x prime y. Is that okay? By the way, I'm gonna use a term I don't think the textbooks are using it. Okay? If you represent the function in min terms this way, this is the most unsimplified function. That's why I used the term last time. It's like a row function. This is the most unsimplified. Okay, most unsimplified function is this one. Okay? Anyway, so here, so here, if I have, for example, if I give you a map this way, and even if I ask you write the function of this map without simplification, I didn't talk about simplification yet. So yeah, you can say I can see in this map we have 2 ones here. It should be midterm. So if I just give you the map and ask you to write the function, okay? So this one is actually midterm number 1 or midterm number 2. And midterm number 1, here, midterm number 1 is actually y x prime. You know why? Simply because this is in the area of y. This is also something you need to learn, okay? If I tell you M1, can you get the midterm of this one? Yeah, someone can tell me, you can do it in different ways. You can say 1 means 0, 1. And this one is x, this one is y. So this one should be x prime y. You can calculate it this way, okay? Or as a you can do it here in the table here. You can see this one in the area of y. So I'm going to use y. This one in the area of x prime. So x prime y. You got what I'm saying? So what I'm saying, you can find the midterm from the way I made this map. Okay, if you look at this one here, what is the midterm here? How can you calculate this midterm? It's actually x because it's in the area of x, and then it is y prime. So x y prime. You understand what I'm saying? Anyway, so I can say this function without simplification. I didn't talk about simplification yet. What I'm saying, given a function, a map, I can represent it in midterms this way, okay? Also, I explain, if you know the one here, how can you calculate this midterm? How can you calculate it, okay? So this way I can say f equal x prime or y x prime. Okay? If you look at here in this case, yes, so again, I can write, so here I have two ones here. One, so actually this should be M0 or M2. Okay, that's what I explained. Nothing is new. That's what I explained. I didn't do any simplification yet. Okay, so this one here, how I can get the equation of this one? Very easy. This one is the area of y prime because this is the area of y. It is in y prime, and this one is x prime. So this one should be x prime y prime. Okay. What about this one here? Very easy. This one is in the area of x and y prime, so x y prime. Okay, so this one has to be here x y prime. Okay, guys. Again, what I'm saying is, if you understand in case of two variable, three variable will be much easier. It will be easy because again, I will repeat everything again, but there may be some little differences, but everything will be the same. The idea of regions, the idea of midterms, everything will be the same. Okay? Any questions? So again, this is not simplified. Here I represent the function as the summation of midterms. Okay, nothing is new. Okay. Any questions? Okay. Before now, okay, how can we do simplification? Simplification. So look here. To do simplification, the way I'm gonna make it, I'm gonna make groups of ones. Okay, so I'm gonna make groups of ones, and every group of ones is represented by one term. Okay, so here in this case, because I didn't do any simplification, so yeah, I took this one like one group. This one is represented by one term. This one is represented by one term. Okay, here, same thing. I took this one as one group. Okay, which is here. I took this one as one group. I put it here. Okay. But as I'm going to explain right now, you can actually group these two together. So instead of taking it individually, two groups. Okay. No, it's allowed. I'm going to tell you why. It's allowed to take these two together and then make it only one group. So neighbors. Okay. I can group neighbors together and take them as only one group. Again, one group means one term. Okay, so here, what I did here, I took this one alone separately, I took this one separately. This made one term, this will make another term. What I'm going to explain right now is, if you have neighbors, I can combine them together, make only one group with only one term. That's what I'm going to explain now. But before I proceed, can you tell me what do you mean by neighbor? Who is neighbor to whom? Is this one neighbor to this one or this one neighbor? Who are the neighbors? Can you define neighbors? That's what I'm going to explain right now. Who are neighbors? So that's adjacent or neighbors, okay? Neighbors, two squares are neighbors if they differ only by one variable. And the same definition, I will use it in case of 3 variable and 4 variables. Okay? So two squares are neighbors if they differ only in one variable. So look, let's look here. Okay? Let's look at M0 and M1. They are neighbors or not? Okay? Look here. They only differ in one variable here because it's x prime and x prime. The difference here is only in one variable. So the answer is yes. M0 and M1 are neighbors. Okay? So these two here, I can, neighbors means as I'm getting explain, I can group them together, but at least now focus on neighbors. Yeah. So if you have here 1 and 1, these are neighbors. So these two ones are neighbors. Okay. Let's look at, for example, M0 and M2. So again, this here, this way are neighbors. Okay. But look at this one. Do these two are neighbors or not? Okay. I made a rule here. This is the rule. Okay. Look here. Y prime, x prime. So they are differ. They are different in only one variable. So the answer is yes. This one also can be neighbors. Okay. Let's look at these two. M2 and M3. They are neighbor or not? The answer is yes. Look here, x and x. They are different in only one variable. So these two are neighbors. Okay. Same thing. Look at these two here. Yes, they are neighbors. Okay. So again, any vertical line here in this case, any vertical this way or any horizontal can make neighbors. Okay, I give you the rule. Okay, this is the rule to define here. Okay, let's look at something horizontal. Is this two neighbors or not? Let's see. This one has x prime so and y prime. So both of them are different. So these are not neighbors. Any horizontal is not neighbor. Is that okay? Same thing here. If you look at the horizontal here, if you see here, x prime, x, y prime, x. So they are different in the two variables. Here the rule is they are neighbors if they are only different in one variable. So they are not neighbors. So again, that means any vertical or any horizontal can be neighbors, but any diagonal. Okay, let me put. So any horizontal or vertical are neighbors. But any diagonal is not neighbors. Okay, based on this rule I have here. Is that okay, guys? Okay. So now I just made a definition. Okay, I made a definition. Who are neighbors? Just made a definition. Now, how I can use this to do simplification? Because I told you I give you some hint, but I didn't give you the hint. I give you some hint. The hint is if I have one here and one here, I have two options. I can take this one alone as one group, this one as a one group, and this is gonna contribute by one term. This one is gonna contribute by one term. So now the function has two terms. Okay. Or because they are neighbors, these two are neighbors, I can merge them together and make only one group with only one term. That's how we make simplification. Okay. Anyway, so that's what I'm explaining. How can you do grouping? Okay. So as you see here, guys, now if you have this map, how can you calculate the function? Okay. I can calculate the function this way. I can say I have one here and I have one here. So I can take this one as a group, this one as one group. And because this one is a group, so this one is actually x prime 1. I already told you how I came up with this one here. This one is in the area of y. That's why I put y. This one is the area of x. Sorry, x prime. Because if this is x, so this part here is x prime. Okay, we don't write it, but you should understand. If this is the area of y, everything else other than this area is y prime. Okay, so this is the area of y prime. Okay. Anyway, so here this one here. It's in the area of y, it's in the area of x, so that's why xy. Yeah, so one way to write this function is I can write it this way. Which actually, this is like midterms. This is the same thing like SO, sum of product using midterms. So here I wrote midterm 1, and this is midterm 3. Is that okay? It's not simplified. Now, I will do simplification now. Okay. The simplification is, instead of making two groups this way, I can combine neighbors. So this, I know these are neighbors, right? So I can combine them, as you see here, only in one group. Okay? Okay, but in this case, if you combine this one together, what is the term? what term I have to use here? The term is 1. 1, okay, because this is the area of 1. So in this case, I can say if this function, I can make only one group by combining these two together because they are neighbors. And in this case, I can say this function is equal to 1. Why? Because this is the area of 1. Okay. So let me tell you something very important. Look here, guys. This function is a correct function. This function also is a correct function. They are equivalent. Both of them give you the same result. But this one is simplified, this one is not simplified. Okay? Very important thing I'm going to say right now. Okay? What we have to do, we need to cover all ones here. We don't care about zeros for now because we are doing sum product. We don't need to cover zeros. What you have to do here, you have to cover all ones. So what I did here, I took this one like one group and this one like one group. I covered all ones. By this way, you can get a correct function. I'm going to say it again because this is essential, very important. The only way to calculate a correct function is by covering or taking all ones you have. Okay, we should not take any zero. Okay, we need to cover ones. So when you cover ones, I did here in this simple example, I did it in two ways. One way, I took this one like one group, I took this one like one group this way, and that's why I got a correct function. Okay, I did it in another way. I took the two ones here, okay, I made them only one group, and this group should be y. Okay, that's why I got a correct function. These two functions are doing exactly the same thing. These two functions are equivalent. If you make the truth table for these two functions, you will get the same result. Okay, but this one for sure is very obvious. This one is much more simplified than this one. Okay. So again, so here just I want to go back again to algebra manipulation to prove to you, to convince you, actually, this function and this function are equivalent. So what I did here, as you see, I can just take y as a common factor, and then y x or x prime equal to y. Okay. So let me tell you very important thing, guys, here. So again, make it simple. Again, you have a truth table. Using the truth table, you have to make a map that has ones and zeros. Okay. Number two, you need to cover all ones to get a correct function. You need to cover all ones. Okay. Number three, you can take the ones individually. So I can take everyone here individually. And in this case, I will make sum of product function. The function that is the same I explained in previous chapter. Okay? It's like min-term or min-term or min-term or min-term individually. It's not simplified. Okay? And that's what you will do today. Okay? Not using maths, but I will ask you to find the min-terms and then do or sum of product. Anyway, yes. Or to have a simplified function, I can make groups. So here I can make this one as one group because they are neighbors. Any neighbors, I can take them as group. Okay. And in this case, I'm gonna have more simplified function because I told you the number of terms in the function you will calculate is equal to the number of groups. So if you have two groups, so I have two terms. If you have three groups, you have three terms. Now, every group is going to contribute by one term. Okay? But look at this important point. Look here, guys. I'm gonna look here. Okay, so you told us any groups, I can combine them together and using one term. Is that okay? But look at the logic. Look here. I told you if I can, these are two neighbors, right? I can combine them together. Is that okay? And he told me if I combine these one together, I can get one because this is the area of one. Okay. So instead of writing x prime y or xy, I can just this is exactly equal to y. Okay. Because if you look here, guys, y is common. Y is common. If I take y as a common factor, okay. So here If you take here y as a common factor, so it becomes x prime or x equal to 1. You got what I'm saying? Okay, this is for this area. Okay, let's take, for example, if I have 1 and 1 here, and I'm going to take these two areas together. Okay, what is the value here? What should be the value if I take this one as one group? Yeah, this is in the area of x prime, so this one has to be x prime, because this is the area of x prime. Okay, same thing. Look here, guys. We have x prime, x prime. If I take x prime as a common, it becomes y or y prime. Y or y prime is actually 1. You understand what I'm saying? Same thing here. If the two ones, if I have a group here this way, this is in the area of y prime. So this term should equal to y prime. If you look here, I just want to link what I'm doing here to the algebra manipulation. Okay, you can find y prime here. But again, the beauty of this one is just you don't need to algebra manipulation. I will just want to explain why when I combine these two together, I'm gonna get y prime. I just want to convince you with that, but you don't need to do otherwise. If I do algebra manipulation, so I'm gonna lose the simplicity of T-maps. Okay, so here you can see y prime is common because they are neighbors, so I can cancel x and x prime. So same thing here. If you have the two ones here, okay, so here you will get x because this is in the area of x. Again, two variables is just very easy. You don't, but again, what I'm going to explain 3 variables and 4 variables, it's going to be the same thing here. Okay, it's very easy because you don't have many variables here, so it's very easy even to do it using algebra manipulation. So see what I'm explaining here. The most simplified expression, I remember last time also I explained what I mean by the most simplified. The most simplified means, number 1, you need to minimize the number of terms. Also, you need to minimize the number of variables in each term. Okay, so if I have two functions, one function that has 2 terms and the other function has 3 terms, which one is better? 2 terms is better than 3 terms. Okay. Also, I have functions that 2 terms and the other one also 2 terms. But here, one term has 3 inputs. The one term here has only 2 inputs. So 2 inputs is better than 3 inputs. You understand what I'm saying? So that's what you should understand. The most simplified function means I want to reduce not only the number of terms, but also the number of variables in each term. Okay. So, and to do that, number 1, you need to cover all ones. If you forget only one, you are not going to get a correct function. So, for example, if I have 3 ones this way, and then I'm going to take this one here this way, and then I'm not going to cover this one in any group. If you don't cover only, you need to cover all ones. If you forget one, the function will be false. Okay. If you cover all of them, you will get correct functions. That's for sure. But you need to ask yourself: is the correct function most simplified or not? To make it the most simplified, you have number 1, reduce the number of groups. Number 2, you have to make as big groups as possible. Okay. Anyways, it's not going to be clear here, but it will be more clear in case of 3 variables and 4 variables. Okay. So here, number 1, you need to cover all ones to get a correct function. Number 2, you have to make the largest possible groups of adjacent one, as I'm going to explain. Okay. So I give you several examples here on 2 variables. Okay. Let's start with this one. I give you the function this way. Okay. Remember last time I told you, okay, we can represent the function in different ways. I can represent the function in 2 steps. That's number 1. I can represent the function in min terms this way, or max terms. Okay. Or I can represent the function using equation, like f equal x, y, or whatever. So different ways. Okay? Anyway, so here, one way I can give you the function this way. These are the min terms 1 and 2. That means these are the locations of 1 and these are the location of ones. Okay, very important to understand this. These are the location of functions. The first step you have to do, guys, the first step you have to do, using the definition of the function, I can either I give you this definition in any way, you have to create a map this way. Okay? So here, this definition is telling me this function has ones in the location of M1 and M2. So all what I did here, I put one here in M1, I put one in M2. Any other school should have zeros. Okay? Because these are the location of ones. Okay, this is number one. Number two, I want to simplify this function. I want to write the simplified one. Okay, so that's okay. So here, can I take these two together as neighbors? The idea, no, these are not neighbors, so I cannot make a group this way. Okay, you cannot make a group this way. So the only option I have is I'm gonna take them individually. So it has to be this way. X prime y or x y prime. So this is actually sum of product. This is, I can't simplify it. This one can't be simplified. Okay? Why it can't? Because I cannot group ones together in this case. Okay? I can't do anything about it. You understand what I'm saying? Okay, this is just one example. Let's look at this example here, guys. I give you this function this way, xy prime or xy. Okay, I can. The first thing you have to do is, if I give you the function this way, you have to put ones and zeros here. How can you do that? And listen to me. Okay, how can you do that? Okay, what this means? Xy prime. What it means? It means this one. All the squares that are in the area of x overlapped with the area of y prime should be ones. Okay? So where is the area of y prime? So this is y prime is this one. This is y prime. Where is the area of x? This one. So the intersection is this one. You understand what I'm saying? Okay. So here, that means if I give it to this way, so that means I'm gonna this one, because of this one, I'm gonna put one. Okay, same thing here. When you see something like that, how can you map it to the function here? Okay. Again, what this one means? It means all squares that in the intersection of area of x and area of y. This is the area of y, this is the area of x, the intersection gives you this square. That means I'm gonna put, because of this term, I'm gonna put here 1. Okay. So here now, this one is a midterm, this one xy prime, the midterm of this one xy. So if the function is not simplified, I can say f equal to xy prime or xy, which is the same thing as this one. Anyway, but I can simplify it. How can you simplify it? In this very easy example, I can combine these two together because they are neighbors. I can combine them together. And once you combine them, the answer, it's going to be x. Yeah, so here, this is a simplified one. So now I can tell you something important, guys. Look here. If the term here has two variables, so this one will be corresponding to only one square. So two variables. If any term has two variables, in case of two variable maps, so this one is corresponding to only one square. But if the term has only one variable, so this actually is going to be corresponding to two squares combined together. Okay. Anyway, so again, guys, if you understand that, I'm going to repeat the same thing again when I go to 3 variables, 4 variables. But for sure, when 3 variables, 4 variables, the map will be bigger. So I'm going to have more options. Here I don't have many options because it's a small one. But anyway, okay, let's look at this one here. Same thing, I'm going to say it again. I give you this one, I ask you to simplify. The first thing you have to do, using the way I define the function. Okay, so here, guys, listen to me. What I said here is the first example here. I give you truth table, and you need to know if I give you the function in the form of truth table, how can you map it to the T-maps? Okay. Same thing here. I explain if I give you the function in the term of min term is this way, how can you map it this way? Okay. Now I can give it in the formula like equation this way. Okay, how can you map it? Okay. In exams, in quizzes, in anything, I can give you any one of these formats. You should know how can you map it, and then you have to work on it after. Okay. So let's see. Again, I'm gonna explain it in a very easy way. Okay, tell me. This one are two terms. You already know here two terms, so this one should be correspond to only one square, and this one should only correspond to one square. Always in case of two variable, two terms are gonna make one square. That's okay. But let's how I can locate this one here. Okay, I'm gonna say it in a different way. Look here, guys. This one means all squares in the intersection of x prime y prime should be ones. Okay, so this is, I know this is y prime. I know this is x prime. Okay, so the intersection is this one. Okay, so here it's the intersection is only one square. So here, because of this term, I'm gonna put one here. Okay, let's look at the other term here. I'm gonna repeat everything again. So the intersection of the area of y and the area of x prime. So this is the area of y, and this is the area of x prime. So the intersection should give you this one. So because of this term here, I'm gonna put one here. Okay. Okay. So here, so as you see here, guys. Okay. So after it's two steps. When I give you a function, you have to represent this function in the map. This is number one. Step number one. Step number two, you have to work on maps to cover all ones, maximize groups. Okay, for every group is going to be represented by one variable. Okay, so anyway, so as you see here, guys, because these are neighbors, so I can combine them together. So instead of taking two groups, every group has only one here. Okay. Again, as long as you cover all ones, you will get correct function. Okay. This is the main thing. But if we look at simplification, so it will be much better for me to combine it this way. Because if I combine it, actually I'm gonna have only one term, and this term has only one variable. Okay. So when I combine this one here, this actually is the area of x prime. Okay. I think I have one more example before. Again, two variables just very easy. Usually we don't use maps for two variables. You can do it, use it, and check that is easier. Okay. But anyway, but what I'm explaining here is the basic or the same thing. I will explain it in three maps. It's the same thing. Also, we're gonna make groups. It's the same thing, but for sure, the map will be bigger. I will have more options and so on. Okay, so let's see here. If I have a map like this one here, guys, so I can make one group. I can take these two together as a group because they are neighbors. Don't forget this one, they are neighbors. I can make it as one group. And once I make it as one group, so this one should be y prime, because this is the area of y prime. Okay, now I'm gonna teach you something else very interesting, something new here. So pay attention to this one, because I'm gonna teach you something new here. Okay, so look, if I have a case like this one, okay, I have here 1, 1, 1, this way. Okay, guys? Again, you need to cover all ones. Don't forget this. Okay? Okay, someone can say, I can combine these two together, okay, and as one group, okay, and then I keep this one alone, because listen to it. It's gonna be clear in when I go for 3 variable and 4 variable. When you make groups, it's allowed to make a group of 1 square, group of 2 squares, or 4 squares. It's not allowed to make group of 3 squares. Okay, so here should be 1, 2, or 4, or should be 8 groups when we go for the other. So it should be 1, 2. For sure, we don't have here 8 squares, but I'm talking about in the future when we have 4 variables. So I can have 16 squares. So you have more options. Okay, so you can have here only 1 square or 2 square tall, but it's not allowed to make any other. For example, 3 you cannot make a group. So I cannot take these 3 together here. This way, no, it's not allowed. Okay. So the options I have, one option I have is I can take these two together as one group, and then I take this one alone as one group. This one option I have. Make sense? So if I do that, here, if I take this one as a one group, it becomes y. If I take this one alone here, this one is in the area of x, it is in the area of y prime, so x, y prime. So now I can make this function this way. Okay? Someone can tell me, okay, but I can solve it in a different way. How? I can make this one as a one group here, this one here, and this one alone. Yeah, you can do that. This one as alone. Okay, so now these are the two groups I have. In this case, this one is actually y x prime, and this one here is actually x. So the answer function is actually x or y x prime. Yeah, you can make it this way. Okay, guys? Okay, but I'm gonna tell you something new and something interesting right now. Okay, actually this function is correct. This function is correct because you cover all ones. It's a correct function. But this one is not the most simplified function. Why? Because actually it is allowed, because the way I can do it, as you see here, I can make one group, I can take these two ones together as one group, and then instead of taking this one alone, I can take it with the neighbor here and make another group here. If I do that, this one here, the red group actually is gonna become y, and this one becomes x. Here I have two groups, here I have two groups. Here I have two terms, here I have two terms. However, because this is a small group, this term has two variables. Because now this one is a bigger group, this term is only one variable. So this one, when this one is more simplified than this one, number of terms is the same, but this one has one variable, this one has two variables. But wait a second, is that allowed, that overlap between groups? Is that allowed? So here, this one here is gonna be part of this group and also part of this group. Yes, it is allowed. You understand what I'm saying? It's allowed to, if this can make it more simplified, that's what you should understand. So I can take this one as one group, and then I can take this one also as one group, and then there will be overlap between the two groups. Yes, I can do that. Any question, guys? This is the new concept or the new thing I want to teach here. The new thing here, guys, is all of us agree I want to make groups as bigger as possible, okay? But now the thing is that if this one already joined one group, can it join another group? Can it do this way? Yes, it can, okay? It can, if this can help you to simplify it. Yes, so this one is actually more simple. You understand the idea of when joining two groups this way, okay? Again, everything I explained here, we have very limited option because we don't have too many squares. Now I'm gonna move to the more practical cases, which is 3 variables and 4 variables, because again, as I told you, usually we use maps for 3 variables and 4 variables. 2 variables, just is the basic one, and you can actually do it using, also sometimes it's tricky, by the way, to do it using algebra manipulation. So for example, if I give you this one, if you wanna, if I ask you to using algebra manipulation to move it from here to here, I think there is one rule here. You can, it may be, I think there is one rule, one of the theorem we have. If you have y and y prime, you can do this way. Anyway, but anyway, just in case of 2 variables, I think it should be easy. You can just use them. Okay. Any questions? Okay, guys. So what I will do right now, I'm going to move to 3 variables. I'm going to read everything again. Number 1, I will choose a map, how the map looks like in case of 3 variables. Number 2, I will show you giving a function, either in truth table, in case of equation, in case of midterms, how can you map this function into the map? I will tell you who are neighbors, what groups are allowed, how can you make groups? So almost everything, but this time in a bigger case. So now I'm going to move to 3 variables. So let's look here. Okay, so So this is the map in case of three variables. So here, these are the three variables: x, y, z, x, y, z. Okay, and this is the truth table as we know it. And this case is actually midterm 0, midterm 1, midterm 2, 3, 4, and so on. Okay, as we know. So here, as I told you, because we have three variables, so how many squares we are going to have? 2 to the power of 3. Because every case should have one square here. Okay, so that's why we have 8. We have 8 squares this way. Okay, and as you see here, this is the area. Let me use a different color. Yeah, so this is the area of y, okay? This is the area of x. This is the area of z in the middle here, okay? And similar to what I said, so guys, I told you this is the area of y. So that means any other squares are y prime. Is that okay? Same thing here. This is the area of z. So all terms here, if you see all terms here have z. All the terms here have z. Because all of them are in the area of Z. Any other squares like this one's here and this one's here are in the area of Z prime. So what is Z prime? This one and this one. Make sense? Nothing is new. That's exactly what I have explained before. This is the area of X. Okay, so that's why you can see it X, 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 X. Any other area, which is this one here, is actually X prime. Okay, guys? By this way, if I do this way, look. So this one actually becomes x prime, y prime, z prime. Why? Because this one is the area of x prime, y prime, and z prime. Makes sense? Because this is x prime. This is y prime, and this is z prime. Makes sense? So by this way, easily I can identify these terms easily by this way. Okay. For example, this one here, this term, it is in the area of x, the area of y, the area of z. That's why I'm gonna call it x, y, z. Because this is square, it belongs to y, it belongs to z, also it belongs to x. Make sense, guys? Is that I'm repeating it multiple times? Is that okay for you? So you can, by this way, any one of them, you can calculate these terms easily. You can calculate these terms easily this way. Okay. For example, if you look at this one is the area of x. This one is the area of z prime, because remember, this is z prime, this one and z1, this part is z prime, this area and this area, okay? And this one in y prime, because y prime is this area here, y prime, okay? That's why I wrote it this one. Okay, guys, any questions? Okay. And now, x prime, y prime, z prime, this is actually corresponding to 0, 0, 0. That's why this one is actually min-term 0, okay? This one is corresponding to 0, 0, 1. This is actually min-term 1. This one is corresponding to 0, 1, 1, which is min-term 3. This one is actually 0, 1, 0, which is min-term 2. Okay? So if I do this way, you will find this is how the min-terms here are, and you will see a surprise here. Look here. This one here, min-term 0, min-term 1. This one is not 2, this is 3. So 0, 1, 3, 2. You see the switch what happened here? Okay. Same thing here. 4, 5, 7, 6. Okay. So based on these terms, this is the term I'm gonna get here is actually term 3. The term I'm gonna get here term 7, not 6. So it's gonna be 0, 1, 3, 2, 4, 5, 7, 6. Make sense? Okay. So now, any question regarding the map, regarding the areas, regarding how I know the min-term is here? So what is the next step? Next step, if I give you a function, how can you map a function, or how can you represent this function in map, in this maps? Okay, and it's very trivial, exactly similar to what I explained before. If I give you the function in a truth table format, something like that, how I can map it here? Very easy, very easy. So you can look here, again, look for ones. So this one actually M1, F1 here, and M4, M5, M7. Okay? So I have to go to these places, M1, M4, M5, M7, put ones. Any other squares are zeros. Very easy. So here, so this one M1, I know M1 is here, I'm gonna put 1. Okay? M4, I know M4 is here, I'm gonna put 1. I know M5 is here, I'm gonna put 1. M7 here, I'm gonna put 1. Other ones, you may not write anything, or you can put zeros. Okay, so other squares are zeros. Any questions? Okay, I can also, if you look at this one here, guys, here I can give you the function this way using main terms. So this function, what this means, when I give you something like that, what it means? It means I am telling you, here, this equation is telling you the locations of the ones are in 0, 2, and 6. That's why here, because 0, I'm going to put at any 0, or main term is 0, main term is 2, main term is 6. Any other one should be zeros. Is that okay? Any questions? Okay, guys? Okay. We have one more thing here is, we have one more thing here is, if, okay, okay, so here I'm gonna talk about neighbors. So, okay, here I'm gonna talk about neighbors. How can you make neighbors? Who are neighbors? Similar to what I did before, because we can combine neighbors together. So first of all, I need to know who are neighbors, so that I can combine them together. Again, I'm gonna use the same definition I used before. Neighbors, two squares are neighbors if they are different or only in one variable. One variable, okay? Using this, look here, guys, who are the neighbors of this one? I will find the neighbors of this square, the square that's in red here, the neighbors of M0 are the vertical and horizontal neighbors. So this one is a neighbor and this one is a neighbor. You got what I'm saying? Can you tell me why? Yeah, very simple. Look here, guys, look at the variables here. You will find it's only different in one variable. I already make a definition. Okay? So also here, this one is a neighbor, this one is a neighbor. Interestingly, this also is a neighbor. Why? Because they are different in one variable. This also is a neighbor. That's why when we explain this topic, we tell you, try to imagine this map is ruled. If you roll this map, so actually this one will be next to this one. If you rule it this way. You understand what I'm saying? If you have a piece of paper here, and if you rule it this way, so actually this one becomes a neighbor like this. Okay? That's exactly what we are doing here. So this one is a neighbor to this one. Don't forget this one. Why? Because they satisfy the condition. They only different in one way. Okay? Let's see more cases. So for example, if I give you this one here, who are the neighbors of this one? Okay, so this one actually is the vertical ones and horizontal ones. Okay, as you see. So this is the neighbor here, this is the neighbor here. Oh, the diagonal are not neighbors. Okay, again, you have here, you have the definition I made. So these are neighbors, these are neighbors, these are neighbors. Okay. Let's look at this one again. Here, look at this one, M2. So this is a neighbor here, this is a neighbor here. So any direct horizontal, direct vertical. Actually, this is also direct horizontal, because imagine it's like you roll it. Okay. Same thing here. Who are the neighbors of this one? This one is neighbor to this one, direct horizontal and direct vertical. Okay. Let's look at this one here. Who are the neighbors? Direct vertical, direct horizontal, also direct horizontal, because this one is neighbor to this one. Imagine it's ruled. Okay, you need to know who are the neighbors, because I'm going to use this information when I create groups. Okay, same thing here for M5. Who are the neighbors of this one? This one is a neighbor here, neighbor here. Direct horizontal, any direct horizontal or vertical. Also, you keep in mind this one also is like vertical. Okay, neighbor. Same thing here. Any questions? Neighbor. Diagonals are not neighbors. Okay. Any questions? Okay. Yeah, that's what I'm saying here. These are not neighbors. So this one is not neighbor. This one, if you don't believe me, you will find there are more than one variable difference. Okay, because this is the definition I made. These are not neighbor. These are not neighbor. These are not neighbor. Okay, because they are not direct. They are not neighbors. This one and this one, they are not neighbors. Okay, any questions? Okay, now groups. We made groups of neighbors, Okay. So now here in this case, I can make group of one, only one square. It can be 2 squares. It can be 4 squares. For sure, it can be 8 squares. By the way, this is very rare case. 8 square means all of them, and this happens when f equal to 1 or f equal to 0. That's why it's not usually it's not an option here. Okay, but anyway, so usually you are gonna make group only 1 square, 2, 4. That means it's not allowed to make group of 3. It's not allowed. Groups should be neighbors, 1 or 2 or 3. Okay. One more thing. If you select 1 square here, you are gonna make a term. Remember, as I told you, you need to make groups, and every group contributes by 1 term in the equation. Okay. So if this group is only 1 term, 1 square, so this one actually becomes 3 variables, as you will see. Okay, what if I can merge 2? I can get a term that's 2 variables. What if I can merge 4? This term becomes only 1 variable. That's why bigger the groups, the better. Bigger groups, better. Because if you can merge 4 together, this will be equivalent to only 1 variable. 2 are going to be equivalent to two variables, this term. Okay? The term here has 3 values. Okay. So 1 more minute, and then we're gonna make the quiz. So again, guys, so I can make this one as 1 group here, and if I make this one like a group here, how can you write the term? Again, this is similar to what I explained before. Remember, this one here in the area of x prime. That's why this one should have x prime. This is the area of x. This is the area of x prime. That's why here, for this term here, I should have x prime. Okay, what about y? So this is the area of y, this is the area of y prime. So this one should have y prime. This is the area of z, this one is the area of z prime. That's why this should be s prime, y prime, z. Very easy. What about this one here? This one is in the area of x, the area of y, the area of z. That's why this one should be x, y, z. Very easy. This here, what I'm explaining, if I can merge two ones together, listen to me, still have 1 more minute. If I can merge 2 squares together, this I can make the term only 2 variables. But how can you do it? Okay, I'm going to tell you how. So if you look at this area here, but again, you already know something. I know if it's only 1 square, so the term has to be 3 variables. If it's 1 square and you don't write 3 variables, so it's wrong. Okay, you know if it is 2 squares, so it has to be 2 variables. You know that. If you don't write 2 variables, it's wrong. Okay. Same thing. If it is 4, so it has to be only 1. Let's look at the 4 because it's very easy. So this 4 in the area of y, so I can say just 1. This 4 in the area of x, so I can write x. This 4 here, okay? But how I can take this? Because these 4 are neighbors. These 4 are neighbors. But these 4 are neighbors? Yes, they are neighbors because you rule it. When you rule it, yes, this one is a neighbor to this one. So yes, these 4 are neighbors, and they are in the area of C prime. Is that okay? In case of 2, for example, if I take these 2 together here, let's look at it. These 2, here. These 2 here. Okay, let's look for y. Yeah, these 2 are in the area of y, so I'm gonna put y. These 2 are in the area of z prime, both of them. But if you look at x, 1 in x, 1 in x prime. In this case, you have to omit x. You have to remove x. You got what I'm saying? Again, I'm gonna say it again. So you look at these 2, they are in y. I'm gonna write y. These 2 are in z prime. I'm gonna write z prime. But if you look at x, 1 in x, 1 in x prime. Half and half. In this case, that means this is because I have to remove 1 term. When you have group of 2, I should have 2 variables, not 3. So I have to remove 1 term. Okay, same thing here. Look here. This one in the area of x prime, right? So I'm gonna write x prime. This is in the area of y prime. But if you look here, half of it in Z, half of it in Z prime. So I'm gonna remove Z. You need to remove 1. Okay? Here this one in Y, this one in Z, but if you look at X, half in X prime, so I'm gonna remove X. Here, this one is in Z, this one is in X, so X is Z. What about Y? Half, this one in Y, but this one in Y prime, so I have to remove 1, because I need to remove 1. In case of two squares, they have to be 2 variables, not 3. So which one I have to remove? The one that is half of it in one, okay, in one group, and the other. So here, these two are in Y. These two are in X prime. But this one in Z, this one in Z prime. So I'm gonna remove Z. Anyway, I think that's enough for today.